All right, here we go. We are on page 144, Star Systems and Galaxies. Okay, this is going to be a long one, and then we're going to have some homework tomorrow. There's some videos to watch. I'll probably, if we do some experiments, I'll try to get those recorded so you can see those. Or not see those, depending on whether or not you watch. Okay. All right, we're on page 141. 141. That would be in your science book. Okay, that should be inferred, but just to let you know. All right, now then. We talk about how on a clear dark night in the country, you can see a hazy band of light stretch out across the sky. Okay, this band of stars is called the Milky Way. Now, it looks as if the Milky Way is very far away, but actually, we're inside the Milky Way. Okay, Earth is actually inside the Milky Way. So you're kind of seeing the outer skirts of it, if you would. If you remember, we kind of set way down and not even in the center of it. Okay? The Milky Way looks milky or hazy from Earth because the stars are too close together for your eyes to see them individually. The dark blotches of the Milky Way are clouds of dust that blocks light from the stars behind them. Yes, Caleb?
So the Milky Way would be that brownish oranges cluster.
Is that cluster? Yep, that cluster, and the stars are just so close together that our eyes almost pick it up as a haze more than just individual stars because they are so close together.
And aren't some of them so far away that it looks like it?
Well, yeah, that's why. I mean, they line up. What I'm saying is, but there's so many of them in one place. Yes, they're actually very, very far apart. It's not like they're bumping into each other or anything. But. Okay, so our solar system has only one star. We know that, okay, and that's our sun. But this is not the most common situation for stars. Okay, you got a lot of stars that are members of groups or two or more stars. That is called a star system. Okay, so if it's got two or more stars, it is referred to as a star system. And then we're going to break it down even a little bit more than that. Okay. If you were on some planets, you would actually have two suns. Some you would actually see two suns. But there would be times that one of them would be down below the horizon. So you would actually only see one sun in the sky at some point in time, but the other one would be below the horizon, which means that planet is probably always lit up. Okay? Yes, Caleb?
Okay, so two things. So a solar system is when you have one star, right?
Our solar system has one. That's the sun.
Okay. Anyways, on Tatooine.
Yeah.
On Tatooine in Star Wars, it has two suns.
Okay, so now we're bringing Star Wars into it. All right, here we go.
Draw a pumpkin.
But he is correct. He is correct. All right, multiple star systems. Star systems that have two stars are called a double star or a binary star. Okay? Bi, of course, being two. Think about bicycle, two wheels. Okay? Those with three stars. Now, this is a very tough scientific term, so try to keep up. Okay? If they have three stars, they're called a triple star.
Wow! Oh my God! So surprising.
All right. Now you do have two stars in the nearby star. Anybody know what the nearby star is? Not our sun, but the other one.
Proxima Centauri.
There you go, Proxima Centauri. May be part of a triple star system. The other two stars is Alpha Centauri A and Alpha Centauri B, which forms a double star. Now, scientists are not sure whether Proxima Centauri is really part of that system or just passing close to those two stars. So it might be a triple system, or it may not. So we don't know. We're not 100% sure.
Well,
Okay?
technically, we might be sure right now because this book is like so.
Okay? Often, one star in a binary star is much brighter and more massive than the other. Okay? astronomers can sometimes detect a binary star, even if one of the stars cannot be seen from Earth. Only one of them can be seen from Earth. Okay? They can often tell that there's a dim star in a binary system by observing the effect of the gravity. So they do have a gravitational effect on each other, and they can pick up whether or not there's two stars, and I'm going to say in close proximity, but we're not talking, right next door to it, but close enough that there is a gravitational pull between the two of them.
No, the funniest is when there's like.
Why do you just start talking? Raise your hand, I will call on you. Yes, Leo.
The funniest, no, it's so weird to see like a plane and another plane, and they're going the same direction. It's kind of like with the thing next door with the planets, but they're going, and it looks like they're going to slam into each other, but they're actually like miles away. It's just like one's like really far away and the one's really close, but it looks like they're running into each other.
Y'all remember Leo? Leo likes to talk.
Mr. Sackmore is so
He's
impressed.
quoting some very, very good stuff. Stars that are really far away appears like they're going to bump into each other, but they don't because they're really far away from each other. But he is correct. He is correct. No, he's right. I'm not kidding when I say he's right. Okay. All right. Now then, as the, I forgot where it was. Thank you, Leo. They can tell that there's a dim star in a binary system by observing the effects of its gravity. As the dim companion star revolves around the bright star, the dim star's gravity causes the brighter star to start wobbling back and forth a little bit. Okay? That would be weird to see. Imagine watching a pair of dancers who are twirling each other around, and even if one dancer were invisible, I'd pay to see that. Actually, I guess you'd pay not to see that. You could tell that the invisible dancer was there by watching the motion of the visible dancer. If they're swinging each other around, you could tell something. There was a force helping to spin it, is what it's saying. Okay. All right.
The invisible man.
The eclipsing binaries. A wobble is not the only clue that a star has a dim companion. A clue that a star has a dim companion. A dim star and a binary star may pass in front of a brighter star and eclipse it. Okay, so if you're sitting and looking at, and you can pick up a bright star, and it's got another star nearby, a binary star, and they are orbiting out there. When the dimmer one comes into view, it's going to eclipse the bright one. Okay. So that's another way that they can tell it's a binary system. Okay? So a system in which one star periodically blocks the light from another is called an eclipsing binary. Okay? Planets around other stars. In 1995, astronomers first discovered a planet revolving around yet another ordinary star. And they used a method similar to the one used in studying binary stars. They observed that a star was moving slightly towards and then away from us. So it's orbiting. Okay? They knew that the invisible object causing the movement didn't have enough mass to be a star, so they inferred that it was a planet. Okay? Without actually being able to see it, they just inferred that it was indeed a planet because they knew something was out there. It didn't meet the characteristics of a star, so they inferred that it was probably a planet. Yes, Leo?
How many confirmed planets? Is it just the 8, or they're like?
Well, in our solar system, this is out of our solar system.
So like
there's hundreds of other planets out
that
there.
they found.
And that's just that we found.
Yeah, that's just that we found.
Ton of more.
There's
That's
many
all
of
that
them
we
out there.
found.
Just that we have found. But in our solar system,
I was
yes,
just
it's
wondering
just
because like it was talking about it, but like I know there's planets that are. Okay, I know that there's planets bigger than Earth, but like are there any planets that are bigger than Jupiter?
Probably, but probably
that's
as you get out there, you're going. But again, there's so much we still don't know. Since then, astronomers have discovered more than 100 planets around other stars, and new ones are being discovered all the time. See there, answered your question. If you just held on. Most of these new planets are very large, with at least half the mass of Jupiter. A small planet would be hard to detect because it would have little gravitational effect on the star's orbit. Okay? Could there be life on other planets in the solar system? Some scientists think it's possible. A few are using radio telescopes to search for signals that could have come from natural sources. We have done that for years. We've been sending up signals into outer space to see if somebody would try to respond to us. So far, nothing. Okay? Now,
Then again, in 100 years, something might come.
you never know.
Just because he's so far out.
A star cluster. Many stars. Well, that is possible because they just talked about how the Hubble telescope picked up a supernova exploding, and it's so far out that they predict it probably was about 70 million years ago that it happened. It's just now, the light is just now reaching
Are you
us.
serious?
Yeah.
Wow.
Is that not weird?
That's
So you're seeing something that happened 70 million years ago.
That's scary. 7 quadrillion.
Mr. Simon,
It's
it's
so scary.
Yes,
Okay.
that's why. Maybe it's like aliens.
All right, let's pull it back together. Pull it back
I
together.
would give Mom a
Pull it back together. Guys, I'm filming this. Everyone in God's creation sees I'm trying to get you to stop talking. I've got witnesses. Yes.
So maybe we've already made contact. It's just taking a while for it to come back.
It's purely possible. It's purely possible. That might be a Christmas present. Who knows? Okay. Many stars belong to a larger grouping called star clusters. All of the stars in a particular cluster forms from the same nebula at the same time, or about the same time, and are about the same distance from Earth. Okay? Now, there is two major types of star clusters. You have the open cluster, which have a loose, disorganized appearance and contains no more than a few thousand stars. Okay? So an open cluster has just a few thousand stars. And they often contain many bright supergiants and much gas and dust. Okay? In contrast, you've got the globular cluster, and this is a large grouping of older stars. Okay? A globular cluster are round and densely packed with stars. Some may contain more than 1,000,000 stars. Okay? 1,000,000 stars in a globular. Okay? Now, talking about galaxies. Yes, Spears.
Can I use the bathroom?
Sure. A galaxy is a huge group of single stars. Okay? Star system, star clusters, dust, and gas bound together by gravity. There are billions of galaxies in the universe. The largest galaxies have more than 1,000,000,000,000 stars. Okay? They classify most galaxies into the following types. You've got spiral, elliptical, and irregular. Okay, and we're going to talk about each one of those. Okay? The spiral seems to have a bulge in the middle with arms coming off of it. You'll see that at the top of page 144. Okay? That is the Milky Way galaxy. Okay? The spiral arm contains many bright young stars as well as gas and dust. Okay? Most new stars in spiral galaxies form from these spiral arms. Relatively few new stars are forming in the center. Okay, so most of the new stars are being formed in the arms. Okay? Some of them will have a bar that comes across them, and they refer to that as a barred spiral galaxy. Okay? Now, an elliptical galaxy, not all galaxies has the spiral arms. An elliptical galaxy looks like a round, flat ball almost. Okay? And they contain billions of stars, but have very little gas and dust between the stars. And because there's little gas or dust, stars are no longer forming in elliptical galaxies. Okay? Most of them contains older stars.
Or on the other hand, the spiral galaxy
It
contains a lot
is
of
making new
stars
stars on a regular
because
basis.
there's so much dust and particles
That's it.
everywhere.
Yep. the sparrows are making. Now, irregular, anybody know what irregular means?
Not like an actual shape.
Not regular.
Yeah, not, an example, my mother, when I was growing up, my mom worked at a clothing factory, okay? And they made shirts. And sometimes a shirt would get run, actually probably more than they liked. A shirt would get run where maybe one sleeve was a little bit longer than the other, a buttonhole was off, maybe a buttonhole was missing, something of that nature. That's irregular as far as clothing is concerned. It's not quite the way it's supposed to be. It's a little bit different, okay? So they couldn't sell that in stores, okay? So that's kind of irregular. It means it's off a little bit, maybe, okay? Some galaxies do not have regular shapes. These are known as irregular galaxies. Irregular galaxies are typically smaller than other types of galaxy. They generally have many bright young stars and a lot of gas and dust to form new stars. And you can see by the picture, it's kind of off-kiltered compared to the others. Okay? Quasar. That used to be a name of a TV company. They made quasars. Yeah. In the 1960s, they discovered objects that was very bright, but also very far away. And many of these objects are 10 billion light years or more away, making them among the most distant objects in the universe. These distant, enormously bright objects look almost like stars. Since quasi means something like in Latin, these objects were given the name quasi-stellar objects, or quasars. Okay? So, what could be so bright at such a great distance from Earth? So they concluded that quasars are actually active young galaxies with giant black holes at their center. Each of these black holes has a mass 1 billion times or more as great as that of our sun. An enormous amount of gas revolves around the black hole. The gas heats up and shines brightly. So that's what they're seeing as a quasar. It's the gases around the black hole that is glowing. Yeah. Okay. And the Milky Way on page 145, you see the pictures there. You see the side view, and it shows you the sun's location, and then it shows you a picture of what they think it would look like from the top. Okay. Now these are not actual pictures, because we haven't been outside of our solar system to get pictures, but they have taken various pictures, and because of that, they have pieced together what they feel it looks like.
Well,
Yes, Caleb?
It may look from the side view like it's not that wide, but it's actually very, very
Yeah.
wide.
It's like a
Yeah,
sunset.
yeah, the picture can be a little misconceived in there. It's not just that thin. It's
They
actually,
say
it's actually pretty wide.
Apparently, it's about 100,000 light years.
It's about 100,000 light years across. It really is.
Across,
Yeah.
yeah.
It's it looks like a sunset from the side
Yeah,
view.
yeah, it does. It does. Okay? So Earth's solar system is located in the spiral galaxy called the Milky Way. You knew that. Okay? And you see the pictures up there of the shapes of it. Okay? From the side, the Milky Way would look like a narrow disk with a large bulge in the middle. From the top or bottom, it would have a more spiral pinwheel shape. The Milky Way is usually thought of as a standard spiral galaxy. However, recent evidence suggests that the Milky Way is a barred spiral
Wait, a
galaxy.
what?
Okay? It has a bar across in the middle of it. Okay? When you see the Milky Way at night during the summer, you're looking towards the center of our galaxy. The center of the galaxy is about 25,000 light years away, but it is hidden from view by large clouds of dust and gas. However, they can study the center using X-rays, infrared radiation, and radio waves. So they're trying to figure it out. Now, if you flip over on page 146, and we're going to look up some of these things, the Cat's Eye Nebula and things like that. There's some really interesting stuff. That's what we're going to do tomorrow. We'll look at some video or some pictures, not necessarily video, but pictures of a lot of these things that Hubble Hubble telescope has sent back and all. It's pretty interesting stuff out there, and a little scary. But the way they define these things, okay, they define the universe as all of space and everything in it.
Yeah.
The universe is enormous, almost beyond imagination, okay? So they study objects as close as the moon and as far away as quasars, okay? They study incredible large objects such as galaxies that are millions of light years across. They also study the behavior of tiny particles such as an atom within stars. So, since the numbers that they deal with are very large or very small, they use scientific notation. Scientific notation, okay? To describe sizes and distances in the universe. Now, a scientific notation uses powers of 10 to write very large or very small number in short form, okay? For you guys that understand how an exponent works, when you see something down here that says 10 to the 15th power, that's not 10 times 15, that is 10 times 10 times 10 times 10 times 15 times.
Or 1 and 15.
Or if you wanted to put down, if you wanted to write down 10 and put 15 zeros after it, you'd have to do the exact same thing, okay? So that's how, but they do that, and so instead of having to write that long number out every time they're talking about this, they write it that way, okay? And they use the 10 because it's easier to work with, okay? So that's what scientific notation is, okay? And the rest of it gets into the math of it. Since you guys are already taking a math class, and this is kind of like a introductory to astronomy, we're not really in 6th grade. We're not going to worry about getting into the math of it, although there is books, astronomy math, math of astronomy, things like that. So there's a lot of math involved in this. There really is. Okay? All right. Bye-bye.